Okay, so here's a quick run through of Excel and what you need to be able to do for the lab submission for the Excel laboratory. So here I have two sheets already prepared with titles and units associated with each one of these. The correction should also be in milliliters as well. Okay, so I'm going to be using some lab data from the laboratory. So again, your data will look differently. Just realize that the process and the equations that I'm using are going to be the same. So the data that I'm going to be using today, this group had a temperature of 24 degrees Celsius, and that means that we need 24.0 all the way down. Notice that Excel has already rounded mine and I don't want it to, so I need to use these buttons here to use and maximize or minimize more decimal points. So I only need one decimal point here. I need this to be the same for all of these. So as you can see, I drag and drop, and that gives me all 5 values of temperature Celsius because we are considering the temperature to be constant in the classroom. Okay, now the mass of the bottle that we were using, not the flask, we used a bottle, the plastic bottle. The mass of the bottle we're using, we're also going to consider that to be constant as well. So the mass of the bottle for this group is 14.81, and that's going to be constant for these 5 experiments. Okay, now when we measured and dispensed approximately 10 milliliters, after each one of those dispensements, we have a mass of bottle flask that we should have recorded, and that is a function of the balance, the data from the balance. So here is our data from the balance for these particular group. And as you can see, each of these values goes up by approximately 10. And that's what we want to see because we added approximately 10 milliliters of water. Okay, so once we have this data, this is all inputted data. And the inputted data here is giving us an opportunity to calculate the mass of water by calculating the difference between these two, and that's a simple subtraction function. So this is equal to D2 minus C2. Enter. And again, we should approximately get about 10. Now if we drag this down, this will fulfill all of these functions for us, right? And we notice that the mass is increasing by 10 approximately each time. All right? Okay. The dispensed volume can be calculated one of two ways. You can do it by hand and subtract the final volume reading from the burette, subtract the initial volume reading from the burette from the final, or you can measure the dispensed volume, calculate yourself, not have to put in the Excel, and then just input that here. So to input that here, we're looking at approximately, let's say, 10.010. And for us to get the proper number of significant figures for our instrument, we need 2 decimal places. Okay? And let's say the dispense volume here, 20.05. And let's say the dispense volume here was 30.10. And here we say it's 40.20. And then here we say it's 50.00. And again, all 3 of these need to be taken out to the proper number of decimal places. Okay, so now we have a dispense volume. To calculate the true volume is calculated by taking the density at 24 degrees Celsius and dividing the mass by the density, right? So if you want to put the density value in here, you can. You can add a column. How do we do that? We do insert, and that gives you a new column, and you can say density at T, which is grams over milliliters, and you can input that value. That value for this particular is 0.99731. 0.99731. And that's the same for all of these. Notice it has done another job of rounding it again. How do we fix that? We add the decimal places. Okay, so now we have the density. Let's say we don't want to input the density each time. Then the true volume is equal to F2, which is the mass of water, divided by FC2. Enter, and there we have the true volume. And if we drag this down, we get the true volume for all of our 5 measurements, which is what we are looking for. And all we want to know now is the correction, right? And the correction is equal to the true volume, H2, minus the dispense volume, G2. And we see that we have a negative correction here out to 2 decimal places, and we have a negative correction for pretty much all of our measurements out to 2 decimal places. Now, you all will have numbers that look different. You may have a positive correction. Either way, the negative correction is fine. What you are going to want to do is to have a calibration curve for the 50 ml burette that is a function of correction versus true volume, dispense volume, which is here. So we're going to drag and collect and highlight both of these and insert. Well, let me say this. On a PC, it's going to say be a table that a tab that says insert. On a Mac, it's going to say charts. But on a PC, you're going to go insert, scatter plot, marked scatter, and you see that we have this correction graph here. And the correction graph shows us that we have some kind of correlation here. So maybe we could change this number to 4.05 and maybe it'll lighten it up. Okay, so this looks a little bit better. We see we have a correction chart, and we see as we get closer to 50, we have a less correction needs to be made. To add a trend line, you're going to right click, even if it's on PC, and then you're going to go linear trend line, and then in your options, you're going to go R squared and equation of a straight line. And you can put that in there. Now you also want to label these, so you can go to chart layout and add a axis and grid line, and to add that. But that's just your basics, how you should input it, how you should set it up. Okay, for the pipettes and the flask. So for the pipettes and the flask, this is a little bit different because you're adding data for 3 trials of the same experiment. And so the numbers that I'm going to use for this, the mass of the bottle is going to be the same. The temperature is going to be the same. So I'm going to just copy some of these. Temperature is the same for all of these. The mass of the bottle is going to be the same. Again, having to type these in each time, use your copy and paste function. Now, the mass of the bottle plus the flask is going to be different for each of these. So for the 5 ml pipette, we got 19.78, 19.74, and 19.74. Okay? Here, 24.85, 24.85, and then 24.85. Very consistent on those. And then for 100, this number is actually different. 73.54, 73.54, and then 73.54. And then our mass is 172.64, 172.66, 172.20, 70. Okay. So, again, this is inputted data, but to get the mass of water, we're doing a subtraction equals D2 minus C2, enter. And we want to drag that for each of these 3. We want to have D6 minus C6 and drag that for these 3. And then we want D D10 minus C10 equals D10 minus C10 for this one. And we have these three. Okay, so now we have the mass of water. Now we want to dispense volume, and see the dispense volume, or the volume that we're using, is a function of these values. So these should be the same for all of these. 5.00, 5.00, 5.00. Again, we want to see our decimal places like such. This should be 10.00. Drag, go over 2 decimal places, and then this should be 100.00. Drag, and go over 2 decimal places. All right. So the true volume, again, is calculated from the temperature Celsius plus the density. And remember, we can insert this if we want to. Go get our density value, right? Our density value is here. And we can copy that into these 3 cells if you want to keep it strictly in Excel. And now to get the true volume, we have equals F2 divided by C2 for each of these. All right, we only have 2 decimal places, so we need to change this to 2 decimal places. Okay, and then the same thing here. F6 divided by C6. And then we want this to 2 decimal places. And then this is equal to F10 divided by C10. And we need these to 2 decimal places. So now that is all of the data workup that needs to be done for this particular and then to get our correction, remember our correction is true volume H2 minus dispense volume G2. And you could drag all of these and then delete the ones that you don't need. And you see that we should have 2 decimal places for all of these. And being that we have 2 decimal places for all of these, then you can get the average correction. To get the average, you can label this as average. And you can show the average in these boxes. And you can highlight this. I'm going to make this very clear that these are the averages. And in each of these boxes, we can go equals, average, equals, average, equals, average. And now we have an average for each of our corrections, for each of our different types of glassware. And that average correction is what is being asked of you in the laboratory, is to get the average correction based on each of these. There's no graph associated with this. Again, if you have any more questions, feel free to see me during office hours or send me an email.